In this presentation, I am going to explain matrix method of mesh analysis of DC electric circuits. And this topic is for first year BTech basic electrical engineering course. Now let us see mesh analysis using matrix method. Mesh analysis using matrix method involves setting up a system of linear equation in matrix form, typically expressed as voltage V equal to I into R, current into resistance, to solve for the loop currents in an electrical circuit. And the process involves constructing a resistance matrix R, and a voltage matrix V, and a current matrix I, and then solving the equation using matrix algebra method like Cramer's rule or matrix inversion to find the unknown mesh currents. For you have to find out the unknown mesh current. For this correct example, three mesh current, circuit here, mesh current 1, that is I1, I2 and I3 are there. These are the three mesh current unknown mesh currents, and we will have to form a matrix equation relating the voltage vector V or voltage column vector V equal to current column vector into the resistance the matrix. Therefore, we have to prepare or make an equation like V equal to I into R. Now we'll see the coming slides how we can make this matrix equation. Now continuing the mesh analysis using the matrix method. As we have seen here, I'm considering this is a 3-mesh circuit. This is a mesh 1, mesh 2 and mesh 3, and we are considering the mesh current as I1 in clockwise direction, I1, I2 and I3. These are the resistances, and we can see that one here, the resistance are marked here, and for the resistance are R1, R2, R3, R4 and R5, and the voltage sources V1 and V2. Now, the general method is that identify the meshes and set up the matrix equation. For that one, first we have to identify the loops. Here in this circuit, there are 3 loops are there, or 3 meshes are there, mesh 1, mesh 2 and mesh 3. That is, label all the internal loops in the circuit for the currents with a n meshes. There will be n unknown mesh currents. Like in this case, this is a 3-mesh circuit, like 3 unknown mesh currents are there, I1, I2 and I3, that is marked in a clockwise direction. And next one is set up the matrix equation, that is express the circuit in the form voltage V equal to I into R. And in that form that is to be expressed. Or here V is the column matrix of the total voltage in each mesh. That is, what is the mesh here? That is, what is the total voltage in this mesh 1? That is the first element. The second element, that is all the voltage that is coming in the second mesh, like that one. This is a voltage source coming in the third mesh. That is the voltage column vector, and that is equal to V equal to the current I1, I2, I3. That is the mesh currents, and this is the resistance matrix. For V is the column matrix of the total voltage in each mesh loop, and I is the column matrix of the unknown mesh currents. I is the column matrix that is the unknown mesh currents, like the first element I1, the second mesh current I2, and the third mesh current I3. Therefore, this is a column matrix, and this also voltage also is a column matrix, and this is a square matrix. And that one R is a square resistance matrix where the size is equal to n into n. Or for example, if there are n loops or n meshes are there, it will be n into n. Or in this case, there are 3 meshes. That is why it's a 3 into 3 matrix. Therefore, this is a matrix having the 3 into 3 dimension. And here, to construct this resistance matrix here, that is, I marked it as R11, R12 and R13. Second row R21, R22 and R23. Third row R31, R32 and R33. This is the resistance matrix. Now the basic rule here, they construct this resistance matrix here, diagonal elements, that is diagonal elements means R11, like R22 and R33, that is marked as RII. The diagonal elements are the sum of all the resistance in the ith mesh. For example, the first R11 means that the sum of all the elements in this one, that is here R1 plus R2, that is R11. Similarly, R22 is the sum of all the resistance in the second mesh, that is here R2 plus R3 plus R4. Then the R33 equal to, that is diagonal element equal to the sum of all the resistance in the third loop, like this is equal to R4 plus R5. Therefore, like that one, we can identify what are the diagonal elements R11, R12, R11, R22, R33, like that one. So the diagonal elements are the sum of all the resistance in the ith mesh. Then off diagonal elements, for example, here Rij, these the off diagonal elements are the negative of the total resistance shared between the meshes I and mesh J. For example, here R12, this is equal to the shared by first and second mesh, that is this element. Then negative of that one we will be taking. For this element, this is equal to minus R2. Similarly, R21 also, if you see that one, R21 also same as this one, R12, which is equal to between the measures 1 and 2 shared is equal to R2. Negative of that one, therefore minus R2 here also. Like that one, the third one, R13. Here R13 means that between 1 and 3, there is no common element between 1 and 3. That is why in this one it is equal to 0 here. And like that one, we can find out the off diagonal elements, and we can form the matrix equation relating the resistance matrix, square matrix, the column current matrix, and the voltage column matrix, like. And then we can solve this mesh currents using the Cramer's rule, or we can take the inverse of this matrix and we can find out what are the mesh currents I1, I2, I3. Now continuing the mesh analysis using matrix, same circuit I just am explaining. Next, as we have seen how we can form the square matrix, resistance square matrix. Already I explained that one. Next one, we have to how we can make the voltage vector or column matrix of the voltage. In that one, it is that determine, that is a construct the voltage matrix V here. This is a voltage vector. Determine the voltage for each loop. For each loop, sum of the voltage sources in the direction of the mesh current. That is, in the direction of the mesh current, sum of that one. Normally, the assign the sign, that is, a voltage source is positive if the current flows from the negative to the positive. For example, in this case, if you proceed in the clockwise direction, as this is a current direction, but we are assuming, therefore, this is a potential rise. That is why then we'll be taking it is as a positive. Now, if terminal voltage rise, and negative if it flows from a positive to negative. For example, in this case, if you see that one, if in the third loop here, this is a loop or mesh current, in that case, there is a voltage plus to minus, a voltage drop is there. That is why this will be taken as a negative. Therefore, this voltage will be taken as minus in that voltage column vector. This element will be taken as minus V2, and this element will be taken as plus V1. And of course, since there is no voltage source in this, the second loop will be taken as 0. Therefore, that way we can make the voltage matrix, column matrix, like. Therefore, set to 0. If the loop has no voltage source, the value in the voltage matrix is for the loop is 0. If there is no voltage source, for example, in this case, there is no voltage source in the second loop. That is why here the corresponding element equal to 0. That is second element or the column. The second element is equal to 0. Therefore, in this one, if you write this is here plus V1, or that is equal to V1, and here it equal to minus V2, and here it is equal to 0. Then next step is that once we form the matrix equation, we have to solve the unknown currents. The mesh currents I1, I2, and I3 are the unknown currents that is to be solved, and use the matrix method to solve for the unknown currents vector by using Cramer's rule. Normally, we can use the Cramer's rule to find out solve the I1, I2, and I3, and thereby you will be getting the mesh currents. Then you can calculate what is the branch currents. For example, in order to find out the current through this resistance, you have to find out what is the mesh current I1 and what is the mesh current I2, or this current is equal to I1 minus I2. That is the current flowing through this branch, R2 equal to the mesh current I1 minus mesh current I2. Like that. First, we have to find out what is the mesh current. Once we get the mesh current, we can calculate what are the branch currents. Now, continuing the same mesh analysis using the matrix method. Here the R1, R2, R3, R4 and R5. This will be forming, or these are the various resistances. And here the voltages are V1 and V2 are the voltage sources in this particular circuit. And I1 is the current flowing through the mesh. This one is marked as ABFEA, or this mesh. And this is the I2 is this mesh current, and I3 is the third mesh currents. And we can write, as we already seen that one, the equation, that is the matrix, a square matrix having the three meshes are there, 3 into 3 square matrix, in which the first element is called first row, first column. Therefore, R11, then R12, R13, R21, R22, R23, R31, R32, and R33. That into the, the current vector or column vector I1, that's the mesh current I1, I2, the second mesh current, and third mesh current equal to I3, equal to the voltage column vector, which is equal to the sum of the voltage here in each first one. For the first mesh, it is observing here, we can see that one, since the current is entering negative and leaving the plus, we can take it is a plus V1. Here equal to plus V1 we'll be getting, and here there is no source as such. Therefore, there will be in the equation, if you write, will become 0. And the third one here, if you see that as per the direction of the mesh current, here the positive voltage and here negative voltage, also a drop is there. That is why we can say it is equal to minus V2. Here this will become minus V2. Therefore, the matrix R into the column matrix I into I equal to the column voltage vector V. For the diagonal elements, as already seen, the diagonal elements are the sum of the old elements, like R11 equal to, it is equal to the sum of all the elements in the mesh, R1 plus R2, that is R11. Similarly, R22 equal to second mesh, all the resistance element, like R2 plus R3 plus R4, that is this element. And the third mesh elements, that the sum of all the elements, R33 equal to, which is equal to here R4 plus R5. This is equal to R4 plus R5. And the element that is R12 means that common to the first and second mesh, that is this one, R2. Put a negative sign. Therefore, minus R2 here. And similarly, R21 also the common element for second and first mesh. Again, that is equal to R2. Here also minus R2. Here minus R2 and here minus R2. Similarly, R13 means that there is no common element between first and third mesh. That is why the element here will become 0. Similarly, R31 also equal to 0. Then R23, R2 means second mesh and third mesh. Common element is equal to, this is that one, that is second and third. This is the common element equal to R4. Therefore, we'll be putting it is equal to minus R4. And similarly, R32 also equal to minus R4. Like that, we can write the equation, the matrix equation like this one, and we can solve the current column matrix, that is I1, I2 and I3 can be solved using Cramer's rule. That for each loop, sum of the voltage source in the direction of the mesh currents. That is, this already we have explained in the previous slide. How we can form this matrix is a square matrix, resistance square matrix can be built up. Now, continuing the mesh analysis using the matrix method, as I already explained in the previous slide, how we can make this matrix R11, R1, R11, R22 and R33. R11 is the sum of all the elements, R1 plus R2, that is R11. R22 means that the second mesh, what are the sum of the resistances, which is equal to R2 plus R3 plus R4, R2 plus R3 plus R4. And the diagonal element, that is R33, which is equal to the third loop, the sum of the resistance, which is equal to R4 plus R5, R4 plus R5. Therefore, these are the diagonal elements. Now, off diagonal elements, okay, for example, this is R12, first row, second column. R12 means that common to the first and second mesh, what is the element? That is R2 is the element. Of course, you have to put a negative sign. Therefore, minus R2 here. Same for R21 also, that is common to second and first, that is equal to this also minus, same thing, minus R2 and minus R2 here. Next, as I told you, there is no the common element between the first and third. That is why we count R13 equal to 0. Similarly, R31 is also equal to 0. Then what is the common element for the mesh 2 and 3? That is R23, which is equal to R4. So this is equal to minus, and then this is a mistake, that one. Therefore, this element, that is R23 means common to second and third mesh. That is, this R4 is that. Therefore, it is equal to minus R4. Similarly, R32, third row, second column, which is also common to third and second, means again R4. That is why it is minus R4. And like that, when we can complete this matrix, a square matrix of the resistance square matrix, and this is the column matrix of the mesh current I1, I2, I3, and the voltage, as we have seen the first loop or first mesh here, the current is in a clockwise direction. Therefore, the current is entering minus and leaving the plus, or that is the potential rise. That is why it is equal to plus V1, or that is V1. And here there is no voltage source. That is why it is put 0. And the third loop, since the current is in clockwise direction, here it is a plus to minus. It's a drop is that is why it is minus V2. Here it is equal to minus V2. Therefore, this is the equation. This is the resistance matrix R into the column current matrix into I equal to the matrix column matrix voltage. This is in the form, and we can solve for the current I1, I2, I3 using the Cramer's rule. As we have seen here, as the Cramer's rule, to find out the current I1, it is equal to delta 1 or determinant 1 divided by determinant, total determinant. We'll be finding out what is the determinant of this one. That is R11, R12, R13, R21, R22, R23, R31, R32, and R32. That determinant is in the denominator, that is delta. And delta 1 means that the first column is replaced by the voltage vector. Therefore, in this case, the first column is replacements, in that when we are doing here, that is, it is equal to, it will become, this will be replaced by V1, here 0, and minus V1. And then we'll be solving, this determinant will be coming the numerator, and this is the denominator delta, and we'll take the ratio that is equal to the loop mesh current I1. Like that one, this is as per the Cramer's rule here, I2, the second mesh current, is equal to delta 2 by delta, or delta means the determinant of this one, and in that, and total determinant of the coefficient matrix is given by same as the determinant of R11, R12, R2, R12, R13, R21, R22, R23, and R31, R32, and R33. The determinant of this one, the denominator, the numerator, since it is the second loop current, the second column is replaced by the voltage vector. Here, as we have seen the previously, it will become, here I'll be replacing the V1, 0, V2, and I'll be explaining in later. Okay. Therefore, in this case, the second column is replaced by the voltage column vector. That is why plus or minus V1, plus or minus V2, plus or minus V3. However, in this case, in this particular circuit, this is equal to V1, and this is second element equal to 0, and the third element equal to minus V2. And this is the, we'll be finding out the determinant of, that is delta 2, and the delta is given by the total of this one, that is R12, R1, that is determinant of this resistance matrix. And then third mesh current I3 is equal to delta 3 divided by delta, where delta 3 means that here the third column will be replaced by the voltage. That is, here generally it is plus or minus V1, plus or minus V2, plus or minus V3 in the third column. In this particular circuit, that is equal to, here it will become V1, and here it will become 0, and here it will become minus V2. And we'll be finding out the determinant, the numerator. Similarly, denominator is same as delta, that is the determinant of this resistance matrix. Therefore, that take the ratio, that will be giving the, the third mesh current I3. Like that, we'll be finding out the mesh currents I1, I2, and I3 using the Cramer's rule. Then we can find out what is the branch currents. We can calculate the branch current. For example, the branch current through this one equal to I1 minus I2. The branch current through this one equal to I2 minus I3. Like that, we can calculate the branch currents. Now let us say a problem here. Determine the current through the 3 ohm resistor, that is this resistor, using mesh current method. Of course, we will be using a matrix method of solving, in which, as I already told, That is, there is a resistance matrix that into the current matrix equal to the voltage matrix. That is R11, R12, R13. Because there is a 3 mesh circuit, there will be 3 into 3 matrix. That is R11, first row, first column. R12, that is first row, second column. R13, first row, third column, like that one. For R21, R22, R23, R31, R32, and R33. And how will we finding out the diagonal elements? That is R11, R22, and R33 as the sum of the resistance in the corresponding loops. For example, R11 means that first loop, what is the sum of the resistance? That is this one plus this one. Or you can say that 5 ohm plus 10 ohm. Sorry, 5 ohm plus 3 ohm. 5 plus 3. That is the total resistance in the first. 5 plus 3 is that one. And the second diagonal element, say R22, we say that second loop take the total sum of the resistance 10 plus, or here, no, sorry, 3, it's not 10. So 3 plus 4 plus 2 ohms. That is, it is equal to 3 plus 4 plus 2 ohms. That is the sum of the resistance in the second mesh. Similarly, the sum of the resistance in the third mesh to get what is the R33 diagonal element, which is equal to, this is equal to, of course, that is equal to 8 ohms, and this is equal to 2 ohms. Therefore, 2 plus 8. Like that, we are finding out what are the diagonal elements R11, R22, and R33. Then, of diagonal elements, we can find out corresponding R12, that is common to first and second mesh. What is common? That is this element, which is equal to, this is equal to common to that one. That is, it is equal to 3 ohm resistance. Common to first and second. That is why it is equal to minus 3. Similarly, here also R21 equal to minus 3. Same thing. And common to first and second, R13. There is no common element. That is why I put 0 here. And similarly, R31 also equal to 0. Then next one we have to find out R23. That is common to the second and third mesh. That is this element. And that is equal to, what is the common to that one, which is equal to 2 ohms. For it is equal to minus 2 ohm. Same as here also. R32 also minus 2 ohm. Like that, we are preparing the first mesh, the resistance matrix is prepared. Or after that one, that into the current column matrix I1, I2, I3, that is mesh current I1, mesh current I2, and mesh current I3, that is equal to the column vector or voltage vector, which is equal to the first loop, that is the first here equal to total voltage in this loop. Total voltage, when you are calculating, if it is a potential rise, we will be taking plus, and if it is a drop, it will be taking negative. Therefore, if you take this mesh here, it is equal to, we can see that one, there is a potential rise here, that is 10. And there's a potential because plus to minus, a drop is there. Therefore, we can take that 10 minus 5. Therefore, 10 minus 5 is the first element here, this element. And the second loop, if you take, what is the total voltage source here? Here, if you again say clockwise direction, we are considering. Therefore, here minus to plus, potential rise. And here also minus to plus, potential rise. Therefore, 5 plus 5. 5 plus 5 is the second loop voltage sources, some of the voltage sources. And the third loop, if you see that one here, again in the clockwise direction, the current is marked here. We are assuming always the current direction in the clockwise direction. Therefore, here it is equal to, what is the thing? What is, we can get this? It is equal to, 30. Therefore, that is equal to drop, because here also drop 5, or minus 30 minus 5, or minus 35. Therefore, that is the third element, that is the one. Therefore, this is the equation relating the resistance matrix and the current matrix as well as the voltage matrix. Therefore, the unknowns are I1, I2, and I3. We can solve these currents using the Cramer's rule. Therefore, reducing this one, we will be getting 8 minus 3, 0, minus 3, 3 plus 4 plus 2. That is 9 minus 2. Again, 0 minus 2, 10. That is, this is the resistance matrix. That into the column matrix, current matrix, mesh current I1, I2, and I3, that's equal to R into I equal to the voltage matrix, or voltage matrix means 10 minus 5, that is 5, 5 plus 5, 10, minus 35. Therefore, this is the equation to be solved. In that one, the unknown is I1, I2, and I3, mesh currents I1, I1, 2, and I3. That can be solved using the Cramer's rule. We'll see in the coming slide. Now continuing the same problem, a 3 mesh circuit as we already discussed. This is the equation what we got. 8 minus 3 0, minus 3 9, minus 2 0, minus 2 10. That is the resistance square matrix. Column matrix, current matrix I1, I2, I3, where I1 is the loop current, first loop, or mesh current I1, and mesh 2 current I2, and mesh 3 current equal to I3, I1, I2, I3. That is current resistance into current, that is equal to voltage column matrix. The total voltage here is equal to, in this loop, equal to, we already got it as 5, and in this loop it is equal to 10, and in the third loop it is equal to minus 35. We have to solve for I1, I2, I3 by using Cramer's rule. For first current, we can say what is I1? I1 equal to delta 1 by delta, in which determinant we have to calculate. This is the delta is given by this, of course, the resistance matrix R matrix, which is equal to the determinant of this one. Determinant of here 8 minus 3 0, minus 3 9, minus 2 0, minus 2 10. This is the delta determinant of this resistance matrix. And to find out this delta 1, first column is replaced by the voltage column. That is, first column is, in that case, the first column is replaced by the voltage. Therefore, that is why the first column, this is replaced by 5, 10, 35, 5, 10, minus 35. And the second and third is same as this one. Therefore, this is a determinant delta 1. And this is the delta, or the ratio of that one determinant is equal to the mesh current I1. That is the by Cramer's rule. Therefore, we are finding out the determinant of that one, that is written here 5 into 90 minus, of course, it is equal to minus 4 plus, of course, here minus signs will come, minus 3. That is why it is equal to plus 3 into, again, 10 into 10, 100 minus 100 minus 35 into minus 2 equal to 70. Or that divided by determinant of this one, 8 into this one into minus this one, or 9 into 10, that is 90 minus 4 here, that plus second one here is equal to, of course, that is equal to minus 3 into here, minus 3 into 10, or minus 30. Of course, this is equal to 0, therefore minus 30. Or we'll be taking the, if you take the ratio of the determinant of this one, we will be getting 520 divided by 598, which is equal to 0.87 amperes. Therefore, the mesh current I1 equal to 0.87 amperes. And similarly, the second mesh current I2 can be found out. Delta is same, delta 2 by delta. Delta is same as this previously already we have seen that delta or determinant of this resistance matrix. And the numerator, the second column is replaced by the voltage column. Therefore, here the first column is same as this one, 8 minus 3 0. Second column is the same as the voltage column. That is 5 10 minus 35. Third is same, 0 minus 0 minus 2 10. Then again the same thing. Therefore, we are finding out the determinant delta 2 divided by the delta and take the ratio, that is the current I2, which is equal to, again we are finding out the determinant 8 into 10 to 10, 100 minus 70. Okay, that minus here 5 minus 5 into here minus 30, then of course plus 0 into, because since it's 0 we can, it will be 0. That is why the numerator is this much only. And the denominator here again, as we already seen here, denominator we calculate as 598. Or if you take the ratio here, 390 divided by 598, it is equal to 0.65 amperes. Therefore, the I2, the mesh current, second mesh current equal to 0.65 amperes. And similarly, the third mesh current, I3 equal to, again we have to solve this one using the Cramer's rule, which is equal to delta 3 divided by delta. Delta is same, that is the matrix, the determinant of this resistance matrix, that is determinant same as this one. And the numerator is delta 3. Delta 3 means that third column is replaced by, here third column is replaced by the voltage column. Therefore, it is equal to 8 minus 3 0 here, minus 3 9 minus 2, same thing. But this column is replaced by 5 10 minus 35. 5 10 minus 35. Again, find out the determinant of this one, numerator, and that is divided by the determinant of this resistance matrix. Or here he'll be getting 8 into, of course, 8 into, multiply this one and minus of this one, we'll be getting minus 315 plus 20. Then again here minus 3 is there. Therefore minus minus 3 means plus 3. Plus 3 into, of course, this one here minus 3 into minus 35. That is, of course, that 105 minus 0. Therefore 105 that is minus 0. And third one plus 5 into this or plus 5 into 6. Therefore here minus 3 into minus 4 plus 6, or that is equal to, we'll be getting minus 2015 divided by 598, or that is equal to minus 3.37 amperes. Therefore the mesh current I3 equal to minus 3.37 amperes. The negative sign indicates that what the actual mesh current is opposite to direction. That's, we are assuming the clockwise direction, but the result is minus 3.37 amperes. That indicates that actual mesh current direction is the opposite. That will be in the anti-clockwise direction. That is the indication of minus sign. Therefore, once we get these mesh currents I1, I2, I3, then we can calculate what are the branch current. For example, this branch current is same as this mesh current I1, that is branch current through this one. Similarly, the question is that what is the branch current through this resistance, 3 ohm resistance? That is equal to I1 minus I2. I1 is already, it is equal to 0.87 amperes and I2 is equal to 0.65 amperes. The difference of that one is the net current through the 3 ohm resistor, 3 ohm branch current or 3 ohm resistor, and that is equal to I1 minus I2, or 0.87 amperes minus 0.65 amperes, that is equal to 0.22 amperes. Therefore, the current through this 3 ohm resistor is equal to 0.22 amperes. Therefore, this is the way how we can solve the this mesh equations using the matrix method.